T'inquiète pas, tu vois, il se met.
Je peux démarrer?
Ouais, tu démarres.
Hello everyone. Hello. It's okay? Hello everyone. Thanks to Minalogic for giving me the opportunity to present my research work. We will talk about data science and economics. And please dive with me in a new representation of the French productive system to understand its deep structure. So a few words about my background. I'm Arnault PACHOT, I'm 47, and I'm father of 5 children. I've been living in Haute-Loire, in Le Puy-en-Velay, for 15 years. I lived abroad in Canada and Georgia before creating the company Open Studio that I currently manage. Passionate about new technologies, I'm really aware about the new challenges of artificial intelligence. And this is the reason why I started a university thesis 3 years ago at the Clermont-Auvergne University on the subject that I will present to you. And I'm finalizing a book that will be published at the editor Duno at the end of the year on the subject of IA and environment. So this project is a partnership between a university and a company. In the one hand, we have the Pascal Institute in Clermont-Ferrand from the University Clermont-Auvergne, and in the other hand, we have Open Studio, the company I created 15 years ago, an IT company providing websites with more than 100 employees. Now we are known as for having a strong technical DNA, and we are involved in open source from the beginning, and we are committed in green IT. So let's get to the subject. So how can data science and open data help rebuild a sustainable productive system? In other words, how can we help local authorities and companies in their decisions? So this is not a simple problem because of some scientific issues. The first one is that we don't know anything about the product that are provided by companies. We only have their industry codes, and we know that it's not precise. We have a lot of data, but sometimes fragmented, just for some region, just for some industry, for example, sectors, or for 1 year. And we have a lot of nomenclatures not always compatible between themselves. For example, sometimes the correspondence tables are absent, and if they exist, they are not precise. And the main issue is that is the lack of visibility of the supply chain. Because the supply chain, the list of suppliers for companies is part of their competitive advantage. So they don't communicate about that. So it's an issue for us because how can we validate our model if the companies do not give us their feedback? So in the one hand, we have several open data files coming from French government or at an international scale, European or international, about companies, products, jobs, some information about the company's CSR, company's societal responsibility, for example. And on the other hand, we have several high-A methods, like the classical machine learning, but we have also word-to-vec and transformer semantic analysis to analyze the websites of industrials. You will see in the next slides that we have analyzed more than 15,000 websites of industrials in order to identify which kind of products they analyze, and the semantic analysis offers to us the possibility to have information about the proximity between classes in nomenclatures linked to their description classes to, if there is, for example, no correspondence table between nomenclatures, we can do the job. So clustering, of course, clusters as an unsupervised method to find clusters in data. Multidimensional scaling, because we use that a lot, because it's to build a multidimensional space based on data proximities. And model-based collaborative filtering, such as matrix factorization, implicit in our case. And matrix factorization is for us to provide recommendations for diversification for the company, as we will know. And also the proximity between items, so products, and users, so companies. A graph learning method, it's deep graph. It's more a new thesis, a new young in OpenStudio that is starting a thesis on deep graph to identify channels automatically in supply chain. And multi-objective and multi-stakeholder recommendation, because of course in our case we have multi-stakeholders, companies, local authorities, with their own strategies. So the scientific foundations are the economic complexity coming from the Harvard University, dynamic systems theory that helps us to measure, for example, the international trade flows, the resilience, the efficiency, the redundancy on each kind of products, observing the import and export for worldwide. And it's about, for example, where there is a few producers and many consumers, for example. So you have here, in this case, a very bad redundancy score, and so we can measure that. Complex system to have resilience improvement factors, and graph theory, data visualization, of course, and the world field of recommender systems. So our goal is first to model, to build a partial twin of our French productive system, in order then to recommend. Okay, so the first step is to model the value chains, the know-how, the proximity between know-hows, the dependency between products and between activities, the HR competencies like HR multi-skill capability for companies, for example, and a robust resilience indicator based on the literature. And that's really important for us to have a robust resilience indicator because it's a dimension that we will optimize in our recommender systems. And on the other hand, we have some use case of recommendation. For example, the look for local suppliers to replace imports, or just to have backup suppliers to improve the resilience of the industry. And the diversification in the case where a company would like to diversify its activity, so we can help this company choosing the best diversification according to her strategy. Relocation is concerning the looking for the best territory to relocate or set up an industry according to the HR dimension and the competencies that are available on this territory. And then the trainings offer, adapting the trainings offer, which kind of trainings we should set on a territory according to the profile, the job that are currently present, and the expected job needed and the proximity between them. So the first use case is about diversification. So diversification, as you remember during the COVID-19 crisis, a lot of companies were able to adapt quickly their offer just to prevent shortages. And because we had, for example, paints or spirit companies were able to produce the hydroalcoholic gel in emergency. And in Haute-Loire, where I live, for example, plastic companies were able to produce medical gowns to replace the garbage bags used by medical staff. And we will interest us on the proximity between two classes of product, like a proximity of know-how required to produce these products. And then we produced a product space that is representing here, each node is a product, and it was read by collaborative filtering by observing thousands of industrial websites, observing and then using semantic analysis also. And here, what is interesting, and we have several clusters here, for example, for agro-industry, here for textile. And the idea for us is to weight the graph according to which kind of company are on the territory. So here, it's an important territory, it's Auvergne-Rhône-Alpes, but we can scale like we want. And as you can see, there are products that are not made on this territory and could be really interesting for deciders or for local authorities to look at this product. So here you have products that are the nodes, and the proximity between the other products are the edges. And if we look, if we dive into a product, we can have, it's exactly the same data, but just another representation. So here, if we, for example, select this kind of product, we have some suggested products that we can provide. We can, so the company can diversify its activity easily through this kind of products. And if you look at the right, there is some weights, because it's a multi-objective recommendation, that the idea is to fit the strategy of the companies or the territories. So you can add weight, for example, if economic score, for example, a competitive advantage you will have diversifying your activity with this kind of product is important for you. Or if it's better to have a best resilience score on the inputs of this product according to the international trade flows, for example, or for territories to improve the importance of basic necessities, as we have seen that there is a big challenge on securizing and being autonomous on basic necessities. Like agro-food or like medicals, for example. And it is made with a relation with the Maslow's pyramid, and it's an interesting work in the literature, doing the correspondence with the product classes, products which are required to produce the basic necessities. In fact, it's the first step called physiological category in the Maslow's pyramid, okay? And we can then weight the products, the diversification, through products with some ecological aspect, like in this case, by setting a weight important on the green production. It's based on open data. Again, all is open data here. And on open data coming from the European Union on the product that are considered as green. It's linked to the taxation. This is the reason why they produce that. So this is in summary the treatments that we have produced to have a personalized recommendation for diversification for companies. And the associated papers, and so we published on international conferences in computer science and economics. So the second use case is looking for a new customer-supplier relation. Okay, so the idea is here to replace, to find competencies locally to replace imports, or to improve the resilience of companies with identifying local backup suppliers. To provide that, we use open data again on IHO tables that are statistical tables. In fact, it's produced by the statistical department of countries, and it's an analysis of financial data on companies, analysis which kind of products enter in the production, in the composition of each one. Okay, the duration of dependencies between products, parts need to product a product. Okay, Sorry. Knowing that, we can, for example, apply that to an example of a company. We know, because of website analysis, which kind of products are made by this company. And then with the IO matrices, we know exactly which kind of entrants are required. And then we can look for suppliers. And again, it's a multi-objective recommendation system that will say that you can add some CSR features, for example, like the gender, the equality woman-man, because it's an open data file we have. But we can extend that with, for example, the scope 3 for the carbon footprint. It could be interesting to look for suppliers who have the best carbon footprint, for example, because you write off on your suppliers' carbon footprint on the scope 3. And what is really interesting here is that because we have the measure of proximity between products, we can recommend alternative suppliers. And it's pretty new. So the idea is sometimes on some territories there is no suppliers for a product, but we can identify which suppliers has a know-how that is very similar to the know-how that is required to produce the product. So the idea is to guide, in fact, new opportunities for suppliers locally to adapt their production tool to find new customers locally. And then here you have, so we built a global potential supply chain. In fact, because as I explained in the introduction, we don't know anything about the suppliers of each company. It's just potential suppliers here. And we can, here is a screenshot on some parts in the Auvergne-Rhône-Alpes. And we can build this big graph and then apply some graph theory methods to have some characteristics. So these are the processes that are implemented, to produce this kind of recommendation. And again, the papers associated, we published in artificial intelligence and economics conferences. So let's go to the third part, the HR competencies. So what is really interesting with HR is that Pôle emploi in France gives us information about the proximity of jobs. Why? Because to help the evolution of careers of guys, and on the other hand, we have information about in fact, we have computed the distribution of jobs through industry codes. So because we analyze hiring declarations, and we know then which kind of jobs, occupations are present depending on your industry code. And then we can provide a graph. Again, in OpenStudio, we like graphs. So here it's a graph representing the products, the jobs, occupations that are currently present in a territory based on the companies and their industry code present in this territory. So in this case, it's not really interesting because it's Auvergne-Rhône-Alpes. So all the jobs are present. But if you select in the atlas a smaller territory, so it could be interesting to find, in fact, a profile of territory according to the needs you have. And we can calculate easily a vector associated with each territory. It all is a multidimensional space, and we can easily calculate a vector according to your needs and look at the more similar, okay? And the other use case is here to find, to identify the trainings, because this is not in the case, again, because all the jobs are present, but if there are law, for example, it could be interesting to identify which kind of occupations are similar to just set a training that can jump, in fact, jump from one job to another easily. So this is a summary of the treatment associated. And then the last use case is the resilience index. As I explained, is an important part. Resilience is the capacity of a system to support a crisis, in fact a disruption shock, and take the level or higher after the crisis. So in the case of industrial, it's to resist the crisis, industrial resilience. So we computed the resilience for more than 15,000 companies, but we can do more. In fact, all the companies in France are in the Atlas. And then we can compute a score of resilience for each territory depending on the product, the companies and their score that are present in this territory. Here, it's a robust resilience indicator based on the literature. And our contribution is that currently you have an expert that is coming in companies and give a score for each dimension, for example. And because we have a modelization of the productive system, we are able to compute that automatically. And this is our big contribution. So, for example, finding is there local backup supplier, so we can find that automatically. Is there a multi-skilled capability for the company? We can compute that automatically based on the graph I presented. Is there any capability of diversification for the company? We know that it's again an important factor for improving the resilience, so we can compute that automatically. And the last one is based on the entrance. As I explained, we can look at the kind of the typology of the networks that are used as entrance for the company and then scores them according to their resilience. So we compute that and we can then display the information for example, industry territories, any kind of scale, or agglomerations. Okay. Okay, these are the one important thing is that we have now on open data the turnover of companies for 2020, and then because we have the turnover of their companies before, so it's we made a model to predict the 2020 turnover for companies, and we compared with the actual turnover, and then this variation is correlated with the presence of backup suppliers and with the scores of resilience of the world trades. And this confirmed that the COVID-19 crisis was a supply chain crisis. So as a conclusion, so we can say again that we have developed, this is an experimental platform, okay? This is not for production, in fact, yet, but we were able to conduct experiments and to recommend for companies and for local authorities. We defined, the modelization allows us to prevent for shortage or estimate the risk associated with each company and each territory. And we measured the resilience index, as I explained. So the next step can be written in several directions. So we work on circular economy in Open Studio, analyzing waste and energy flows again. And so it could be integrated, and we have to finalize some things, but the main tool for us is to develop a bot that can scroll the web to look for suppliers. Because we are, in our work, we were able to read automatically website of an industrial to identify as a vector which kind of product it manufactures. So the idea is to go outside France, to go worldwide and to identify suppliers everywhere, because distributed manufacturing is a world problem, a world issue. And then for territories, for example, where there are no open data on companies, could be a workaround. So thank you very much. I would be very pleased to exchange with you on this project. And even if you are an industrial or even if you are a researcher, okay, it's very cool. Thank you very much. Just to thank the team in Open Studio, because Atlas is a free access, so you can access to it. It is the URL. And the team, it was developed by Open Studio company. Thank you.
Thank you very much, Arnaud. Do you have any question to Arnaud, or there is any question in the chat? No? Thank you for this physical performance first, and for the great and amazing project. When do you plan to make it industrial? When do you plan to commercialize the platform?
Okay. The truth is that it's a research work, but we have a know-how now in Open Studio, and I think we can do personalized platform, okay? Even if it's to find suppliers, to identify, for example, the idea of the principle for having a score for suppliers, for the resilience index for suppliers, could be used for the insurance or any kind of, or to analyze your supply chain and the risk. So in Open Studio, we provide tailor-made websites. So we don't sell products. In fact, we do customized solutions.
Okay. And do you use it for yourself, for Open Studio?
No, because it's only for manufacturing, and it's a limitation. And I hope we can analyze then services companies. Not yet, but it's not. In fact, it's the reason is that we use the harmonized system, that is a famous nomenclature, only on products, because it's linked to the import-export declarations. But we have a CPA nomenclature in Europa concerning services, adding services in the nomenclature. So it could be really interesting to do that. Yes.
Okay. I heard a lot of Europe in your sentences. So do you plan to go and to knock at the door at the European Commission?
So what is really interesting is that there are some projects about, for example, opencorporates.com. It's like we have the information on Fred, that is an open data file for Siren database about companies. And it's just the same thing at the international scale. And in our project, in fact, we have, as you have seen, the Rome French nomenclature for jobs. So we should, I think, use European or international nomenclatures, just because just to collaborate with other researchers worldwide and to maintain a common platform. To research, okay? Okay.
And what are the main feedbacks from the first experiment you make?
In fact, what is sure is that it seems to be easy to analyze the open data files, but because of several issues, as I explained, in fact, it's not so simple. And there is the big challenge is coming from the macroeconomy to the microeconomy, and just because we found a lot of data sets on macro scale that works fine on macro scale, but fails if you analyze a company. And our best success, in fact, it was to analyze the website of Industria to really know which kind of products that work together, produced together, to have a strong similarity index.
It's not for you, the drawing.
Okay.
Is there any question before I leave Arnaud? Thank you very much again.
Thank
Arnaud.
you. Thank you very much.
I take advantage of this between talks to thanks our partner Synedia, who is making a great job for the conferences. And then we have a next talk about biomimetics, and how to innovate with nature. But we have few minutes.